Now let's move on to the different commands you can use in Nmap along with the flag and usage description. So the first area we're going to be looking at is target specification. There's a number of commands you can actually use in this area. Say for example, you like to scan a single IP address. Then so for example, I'm targeting a Ubuntu IP address here, so scan that. And if you want to scan a specific set of IP address, for example here, I'm targeting 3 separate IP address. Got to make sure they're separated by a space, otherwise it's going to trigger an error, and shouldn't take long. Right, so and the next scan will be scanning a range, and essentially that's how you've got to write a command. You've got to make sure that the last 2 digits are separate by a dash, and with the last digit representing how far down the range you want to go to. And that's that. And also how to scan a subnet. A subnet, it's a group of IP address sort of determined by something known as a side notation. In this particular case, we say the mask is 24. It means that we've got 254 usable addresses. There are different masks, 16, 8, but this tends to be the norm. So I think that's an exercise that people tend to carry out in the operation, because you want to identify every possible live host in a specific network. It shouldn't take too long. Usually lasts 20 seconds in this particular case. Right, so it's 25 seconds. And the next scan is it's scanning random host. And it's a bit of a funny one, really, because it allows you to scan random hosts in the internet. Now the question is, are you allowed to scan something which you haven't got permission for? I'm not going to run this scan for the reason I've just mentioned. But it's very useful when conducting research that needs a sample of random hosts. Host discovery. There are a number of scans that you can use in this particular regard. So, for example, you want to scan ports only and disable host discovery, so you can use this command -bn. And if you want to instead carry out a host discovery only and disable port scanning, then you'll be using the sn scan. And say for example, you just want to carry out some app discovery on a local network app, that's address resolution protocol. And there is. So that's the command for that. And also, if for some reason you don't want to carry out some sort of DNS resolution, domain name resolution, this option tends to reduce scanning time. So this is the command to use for it. Right. So that's pretty much it for the host discovery. I mean, there's a whole host of commands that you can use, but these are the main ones. But next we look into sport specifications. There are a range of scans that you can carry out in this context. So for example, you want to scan a specific port, let's say for example port 21, and you can just write that command. But you might also want to scan a range of ports. So for example, we're scanning between 21 and 100. Or you can try to scan multiple TCP and UDP ports. This command, you can structure your command in the following way. You've got to make sure that you specify the UDP scan, and in this particular case I've chosen a TCP connect, a full connect scan. But yeah, you've got to mention these two flags in order for the command to run. So this one require super privileges. And the next one, for example, if you want to carry out, if you want to scan every single port from 0 to 65,535, so the following command will be this one out. So you've got to make sure that you've got a dash before and after the P. It takes about 5 seconds. Okay, so otherwise, if you don't do it, the scan will be by default targeting the top 1,000 ports. The next one is if you want to target a specific service name. In this case, for example, we're targeting HTTP or HTTPS. It could be DNS, it could be SMTP, whatever services you've got in mind. Okay, so you can actually see it actually just filters out the services and the ports of which they run. So you see here we've got that's an encrypted version of the web, and that's the encrypted version. And I think this is Tomcat. Now, if you want to just carry out a fast scan will be scanning the first top 100 ports, and this is the command. You should use that's a dash capital letter F. And if you want to, say for example, scan the top 1500 ports, because by default Nmap scan the top 1000 ports, but you want to go beyond that because you don't want to leave any stone unturned or whatever that is, and this is the command that you have to use. And in this case, we're targeting the top 1500 ports. There you go. So that's pretty much it for port specification. Right, next we're going to move into service version and OS detection. This is quite an important aspect of intelligence gathering. There are quite a few commands that can sort of help us to achieve that. So first one would be, so for example, you want to just detect the version of the service running on the system. So you can run this command -s V. You'll have to bear with me because this command detects at least 10 seconds each. Yes, so there you go. So you can actually see that, as opposed to just having the service information, it also gives you the version, and that's that for just detecting the version. In some cases, you could also add the version intensity. I mean, it might not produce a different outcome, but I mean, if you want to know for the sake of argument which command to run, this is a flag you have to add version intensity, and they tend to have level from 0 to 9. So if we run that, I mean, what this particular one does, it's argued that it could increase the possibility of correctness, but as I said, in my experience, you're less likely to get a different output from the previous commands. The next one is how to detect the operating system of a target. So the command that we'll be using, it's a -O. So this command uses TCP stack fingerprinting, and that's the output of it really. So it gives you much more information. For example, here it can actually tell us which particular operating system we're using, and the version. It gives us the range, so that's quite useful. Intelligence, you can actually use another tool to try to identify exploits related to this particular version. The next one is if you want to actually have a very comprehensive scan. So this one is very aggressive. The command for it is capital I -capital I. So it is very, very aggressive. It enables open OS detection, version detection. It carries out some script scanning as well, and some trace routes. It should take a bit longer than the other commands, but not much longer. There you are. So about 22 seconds. But as you can actually see, we've got much more information than the previous scan. In this particular one, it tells me that I'm connected to the Ubuntu machine. You can actually see that for the RPC binds, it also carries out another command, RPC info, which actually lists every single remote service, RPC services on the remote machine, really. So it's very comprehensive. So it gives you much more information than the previous scans. Okay, let's move on to timing and performance. This is an interesting category. I mean, obviously, if you are performance obsessed, I'm aware that some people have to deal with very, very large networks. Nmap has some fine-grained timing controls built into it. What I did is to put together the ones that are very simple. And they they follow this particular syntax. So they range from T0 to T5. T0, that's the paranoid level. I'm not going to run it because it takes a lifetime. T1 is the same sort of time. It takes also a long time to do that. That's a sneaky level. T2 is meant to be the polite level. It slows down the scan and uses less bandwidth. It also uses less resources from the target machine. And T3 is meant to be the normal ID evasion sort of scan. It's done at the default speed. So that's the one I'm going to run. And you can see it takes about 24 seconds. The next one is T4. T4 is meant to be very aggressive in terms of speeds. And it assumes that you also are on a very reasonably fast and reliable network. So that's pretty much determined by the speed of your network. And the last one is T5. It's meant to be insanely fast. And then again, if you want to sacrifice accuracy for speed, that's the one you have to go for. And that's that for the timing. Now let's move on to the NSC script. NSC stands for the Nmap scripting engine. This is perhaps one of Nmap's greatest features. This scripting engine allows you to use a predefined set of scripts or to write your own using a programming language called Lua. I'm just going to show you a few examples here. Say, for example, you just want to run the default script and trying to scan a target using that, then this is the command you would be using. And I ran it earlier. It takes quite a while, so to spare you the wait, I'm just going to show you the output. As you can actually see, it is very comprehensive. It's very useful for discovery, and it's the same output as the aggressive scan. Okay, so now perhaps you don't want to do that. You just want to run a single script, and the best command to do that will be say, for example, you want to use a binary script. That's just one single script inside the NSC engine, and that should take about 30 seconds. I'm gonna let you see the output to this one, but okay, that's brilliant. So as you can actually see, it took about 20 seconds. So essentially, it just display the banners of the various services running on a target. Now, perhaps you just don't want to run one script. You want to run, say, for example, two scripts or multiple scripts. And for example, here I'm running the discovery script as well as the banner. And you can that's how the syntax should be structured. I'm not going to run it because it takes quite a while, but just to show you how to structure it. But then again, you must, as well as you might want to run the default, but you also want to remove intrusive scripts. So the command to do that will be this one, the non-intrusive one. You run the default script, the default setting of the NSC engine, but you remove anything that's intrusive. I'm not going to run it either because it takes about 3 minutes just to show you what it looks like. But essentially, NSC, it's very, very fascinating. It contains script for everything you can imagine. You can use it to automate system and vulnerability scans, for example. If you want to run a full vulnerability test against your target, this command should be able to do the trick. So essentially, all you have to do is to add the vuln sort of target sort of a script into the command, and that should be able to carry out a vulnerability scanning of your target. As I said, it takes about 10 minutes. I think I ran it earlier. Let me see. That's the app where I ran it earlier. It's about 5 minutes actually. So you can actually see how comprehensive it is, and we've got quite a few CVEs. We've got a slow low risk attack here, and see how you completely scan through every single service. And we've also got another vulnerability here. This is the SSL poodle information leak. But essentially, that's what it does. It's equivalent to carry out a vulnerability scan. And yeah, so um, the next command now, for example, as I said, with the NSE, you can also carry out a brute force attack. Say, for example, you want to carry an FTP brute force attack. You could use this command. There you go. So you just use the FTP brute script, and you make sure that you're targeting port 21 on which FTP is running. I can tell you this one takes quite a while because essentially it goes through possible valid combination of credentials in order to backdoor the server. So I'm going to close that, but just to show you the app because I ran it earlier, you can see how long it took, well over 10 minutes, and it identified a valid credential that could be used to log into the FTP server. So, and it's not just that. Nmap also has got script which allows you to detect malware and backdoors. For example, it has a module to check for popular malware sign inside a remote server, and it also integrates Google Safe Browsing and various total databases as well. So the command, for example, to carry out a malware scan will be structured in the following way. Sorry about that. Right. For example, this command will allow you to carry a common malware scan. So if you do that, it's quite straightforward. It doesn't take long. So that's the reason why we're going to run this. Should take about 20 seconds. There you go. So, and it's quite useful. But so that's just to carry out some sort of malware scan against the target. Or you can also use the Google malware check as well. So if you want to use the Google malware check, say for example, we're targeting port 80, and then there you go. So clearly there's no malware on the target here. Otherwise, you would see something like host is known to have, or host is known for distributing malwares and so on. Now let's look into firewall, intrusion detection system, evasion, and spoofing. Earlier we saw ways of escaping IDS and firewalls and so on, such as using timing and performance or stealth scanning techniques. But I'm going to show you a few commands to add to your repertoire. And for example, this one, this scanning technique will use tiny little fragments of IP packets, which makes it harder for IDS and intrusion detection system in general to deal with. This might require root privileges because of the stealthy nature of it. So that's the one there. Or you can also use a given source port number. That's another way to evade IDS. So you can actually see we've particularly given it a particular port from which to carry the scan. You could also use decoy scans, i.e. sending scans from spoof IP addresses. You might have to line them up together. You can actually see I've got 3 IP addresses lined up together. Make sure there's no space between them, otherwise it generates an error. And the last one is appending random data to send packets. And let me get you the command here so that you can actually see what I'm talking about. So essentially, we're adding extra data to the packet that we're sending just to confuse the intrusion detection system. But that's it about firewalls. Now let's look into output formats. By default, Nmap prints the information to standard output, but most of the time you don't need the Nmap scan to be output to the screen, but instead saved to a file to be used possibly later on. Nmap provides several output types. I'm not going to run them, but I'm going to show you the syntax of each one of those output type. The first one is the normal output. That's the flag for it, dash or capital N, and then you can actually follow it with the file name, say ibc.txt. The other output format is saving the output as in XML format. So in that case, the flag will be dash or capital X followed by the file name, say maybe ibc.xml. The last and most interesting format is the greppable format, and the flag for it will be dash or capital G, and following by the location in which you want to save it. And obviously it makes it easier to be parsed with the standard Unix tools such as grep or concat. I'm just going to show you an example of scanning for web server, say for example in your target network, to identify IPs running web servers. I did it for my target network here. You can actually see here 10.0.5.0, and the subnet mask is 24. So essentially what this command will do, as I say, it will be scanning for web servers and grep to show which IP addresses are running web servers. It shouldn't take too long. And there you go. So we've got two IP addresses running two different types of server. One is Microsoft and the other one is Apache. There's also another output format which will save the output in a three major format all at once. That will be the same command as this one. Instead, the flag should be dash or capital letter A, and the location where you want to save it, maybe results or wherever that is. And you could also append a scan to a previous scan file. In that case, you just got to use the command, the normal file, and then for example the file is abc.txt, which is a location, and then you use the append flag here, dash output, and this command should append a scan to a previous scan file. So that'll be it for the output format, really. Okay, finally, let's look at debugging. Linux ships in with many tools to help you with debugging, including ping, traceroute, netstart, to name but a few. But I think Nmap will give them a good run for their money. But then again, this tutorial is about Nmap. So let's look at some Nmap commands to troubleshoot a network. I'm gonna, say for example, you want to just increase the verbosity level of an output. So this command should be able to help you. There you go. So, and it's quite comprehensive in terms of actually tells you how the ports were discovered and from which particular IP address and so on. So the next one is about increasing the debugging level, and that's the command to do that. And is also give you much more information than just a normal scan and so on. So it's very useful. And the other commands will be to display reasons as to why a port is in a particular state. And if you use this command, use the flag dash reason, you should be able to do that. So you can actually say that it gives you the reason there why the port is in a particular state. It says sin act, quite frankly, it's open. So if you remember the three-way handshake, this is the second phase of a three-way handshake. And another command which would be useful to debug here, it's a command to show you all open ports, or possibly open port really. So this one should be able to do that. And it's just confirming information that you probably can find out from by different means. And also, if you want a command to show all packets sent and received, there aren't that many scenarios you might want to do that, but clearly if you carry out some sort of forensic exercise, then you might want to trace every single packet, and this is a command to do that. You can actually see how detailed it is in terms of information, in terms of source, and whether the connection was established or whether the operation is in progress, and so on. And also another command to show the host interface and routes. And in this command should be able to. This command should be able to do that, the if list. There you go. So it essentially shows you all the host interfaces and the various routes. And the last command for I'm going to show you there for debugging, it's to resume a scan. So if you've already got a command, if you've already got a file from a previous scan and then you want to resume a scan, then you can just type this command. I'm not going to run it, but because I did it earlier. So that's pretty much it for debugging. But as I say, there's a whole host of command out there. I'm barely scratching the surface really, but that's it.